Welcome, Grade 7 learners, to your very first Python Programming Explainer. I am absolutely thrilled to have you here. Today is a massive day because we're going to set up your brand new digital workshop. We are literally laying the foundation for everything you're going to build in this course. You're stepping into the world of computer science, and by the time we wrap up this session, you're going to understand exactly what tools you need and how to start thinking like a true programmer. But before we jump in and start installing tools, we've got to ask ourselves a pretty fundamental question. How do you talk to a computer? Like, if you want a computer to do something, you can't just politely ask it, "Hey, computer, could you please create a cool video game for me?" No way. It doesn't speak English or Spanish or any human language naturally. Computers need incredibly specific step-by-step instructions. They are incredibly powerful, for sure, but they take everything literally. So learning to program, it's really just learning the language and the rules to write reliable instructions that a machine can actually understand. So here is our roadmap for today's explainer. First, your Python coding environment. Second, writing your first program. Third, the power of comments. Fourth, the program development cycle. Fifth, a quick knowledge check. And finally, number 6, your coding takeaway. Let's start with section 1. Your Python coding environment, setting up the workbench. All right, let's dive right into this. Look, any good builder needs a workspace, right? A carpenter needs a solid table. A chef needs a kitchen. Well, as a Python programmer, you need a digital space where all of your tools are in one place. And that digital space has a special name. It's called an IDE, which stands for Integrated Development Environment. This is your digital workbench, the exact place where you write, test, and run your code. You can think of it as a single piece of software that gives you a blank canvas to type your instructions, the tools to check if those instructions even make sense, and the engine to actually run them and see what happens. Let's be real, without an IDE, writing code would be like trying to build a car in your living room. It'd just be messy and totally disorganized. Now, when you start out with Python, you usually have a choice of which IDE to actually use. We're looking at 2 of the most popular ones for students right now, Idle and PyCharm. So Idle is fantastic for beginners. It's super lightweight, it's great for quick, simple tasks, and it comes right out of the box when you install Python. It's kind of like your trusty starter tool belt. PyCharm, on the other hand, well, that's a much more robust tool for larger, complex projects. It has advanced features to help you write code faster. Think of it as a full-blown professional garage. A programmer chooses the right workbench for the job. And in this course, you're going to learn how to get really comfortable navigating whichever one you end up choosing. Moving on to section 2, writing your first program, creating the blueprints. Okay, so you've got your workbench. Now it's time to start writing those actual instructions. But there's a really crucial catch here. You absolutely have to understand something called syntax. Syntax is basically the exact rules and grammar computers need to understand you. Look, if you misspell a word in an English essay, your teacher still knows what you mean, right? But if you miss a single parentheses or capitalize a letter that shouldn't be capitalized in Python, the computer just completely stops. It will throw an error and flat out refuse to run. Following syntax is all about being incredibly precise so your blueprints are perfectly clear to the machine. Section 3, the power of comments, adding sticky notes. Now, as you're writing these highly precise instructions, you're going to need a way to leave notes for yourself. Think of them like little sticky notes stuck right inside your machine code. The official Computer Science Teachers Association standard actually sums this up perfectly. They say, document programs in order to make them easier to follow, test, and debug. And listen, this isn't just a friendly suggestion. It is a professional standard. When you document your code using comments, you're essentially explaining why you wrote something a certain way. It makes your code reliable and readable, not just for other people, but for yourself when you look at it 2 weeks from now and go, wait, what was I thinking here? You know what's really wild about this? It's how these comments actually work in the environment. When a human looks at a comment in Python, they see helpful, totally normal notes explaining what the code does. But when the computer runs the program, it sees absolutely nothing. It literally ignores comments completely during execution. In Python, you just type a hashtag symbol, and everything after it on that line just goes invisible to the computer. It's like your own secret communication channel right there on the workbench. Which brings us to section 4, the program development cycle, the assembly line. All right, let's recap. We have our workbench, we have our syntax rules, and we have our sticky notes. Let's see how all this comes together on the assembly line of software creation. Every successful programmer follows a cycle that looks exactly like this. Step 1 is plan. You never just start typing. You outline your logic, maybe draw a flowchart, or just write out your goals. Step 2 is write. This is where you actually type the Python code into your IDE, making sure you follow those strict syntax rules. Step 3 is test. You run the program to see what happens. Did it actually do what you expected? And finally, step 4 is debug. This is where you identify errors and fix them. And hey, spoiler alert, you'll spend a lot of time in step 4, and that's completely normal. It's all part of the cycle, and it loops right back around as you refine your program.
Section 5. Quick Knowledge Check. Quality Inspection.
Okay, I've been doing a whole lot of talking, so let's just pause for a second to see what you've absorbed so far. Think back just a moment to that assembly line we just looked at. Which step of the program development cycle involves identifying and fixing errors? I'll give you a second to think. Was it the first step where we strategized? The second where we typed? You guessed it, it's step 4, debug. Awesome job if you got that right. Debugging is that totally critical process of hunting down those tiny syntax errors or logic mistakes and fixing them up so your code runs perfectly. It's honestly like being a digital detective, and it is absolutely one of the most important skills you're going to develop this year. Finally, Section 6, your coding takeaway, clocking out. As we clock out of our digital workshop for the day, I want to make sure you're walking away totally empowered. So here's a quick summary of the core tools you've mastered today. First, you know that you need to set up your IDE, whether that's idle for those quick tasks or PyCharm for the bigger projects. Second, you know you must follow strict syntax rules. Remember, precision is everything when you're talking to a computer. Third, you've learned to use comments to document your code, making it totally readable for humans while the computer just happily ignores them. And lastly, you know to follow the plan, write, test, debug cycle to create reliable working instructions. So you've got the knowledge of the environment, you know the tools, and you understand the workflow. The workbench is clean, the lights are on, and your keyboard is waiting. So I'm going to leave you with this one question. What will your first lines of code build in your new digital workshop? Get ready, because in our next session together, we actually start typing. Thanks for joining me on this explainer, and happy coding.